Back on the little jewel project. Got the larger welder hooked up. We're going to be doing some serious welding today. Heavy duty, some 1/2-inch plate, some 3/8, some 1/8. Got some safety gear, got a grinder, and a lot of stuff laid out. So let's see a little theory and a lot of practice. Might be a music video. I'm going to try to get into the details of why I'm doing what I'm doing. Let's go. All right, I'm going to address a couple things first because there was a lot of comments, a lot of good comments, and a lot of comments that made me go, It's clear that some of us, meaning all of us, our community, have no proficiency or imagination in engineering, design, creativity. First, I'm going to say I agree with a lot of people. They had a name for the bearing I will need if I was to do it like everybody else. Other people have said that maybe this axle in the center isn't up to the task. Other people have said that maybe this stamped rim shape isn't up to the task, meaning the leverage of the incredible force of this crane is going to not work. Some people have suggested doing a paper mock-up or a computer mock-up or other kinds of mock-up instead of wasting time and money. Instead of wasting time and money. What's the definition of research and explanation? Could it not be summarized by wasting a lot of time and money? There's also the concern about reinventing the wheel, both of which I think I am not accomplishing. You dig? Spending time and money in an effort to realize my own satisfaction. Not the best case scenario, not man's greatest achievement. A simple crane that, by the way, will stay with the truck. That's part of the feature. That's why I'm not just getting a different scenario. I'm making something creative looking for discussion that actually works. I know it's a heck of a concept to grasp, but bear with me. That's why I framed it with this simple engine hoist. There's been other discussion about mimicking the design of that, of which I think I'm doing. You'll see that other people have said that the shape that I'm creating may deform, but it's not developed yet. I digress. The vertical piece that's canted back is square tubing. It is supported up high. Will I do that with this design? Possibly. Before I put any weight on it, I'm going to test it and consider, but I'm trying to come up with something, and it's a lot of welding to accomplish that. The square tube is said by some to be less prone to twisting, to deforming under weight, and I'm not disputing that, but the design isn't fully realized yet with this H-beam. You dig? The other thing, me taking creative criticism about this rim flange deforming, about the rim in itself never being designed to take a load in that direction. I'm with you, like 100. The thing is, instead of me trying to create this massive structure, drill the holes, etc., for me, the cutting of the plate, drilling of the holes, any kind of machine work like that is the bigger challenge. The welding is straight through, but I don't have a machine shop equipped with a plasma cutter, the necessary things to lay out a perfect bolt circle like this rim provides. The hardware, the lug nuts, everything, it all comes in these different mashup ideas of other things that exist. So the rim is stamped steel. Hopefully we can see that. And this is the thing. This piece here will be laying and contacting the bearing, right? So a bunch of people said that this is going to fold in, and I'm with you there. So what I've done is I've got this plate that fits right in here. Hopefully the engine hoist isn't blocking it. I'm going to take a look right now. You know, you can't really make that up. Some may say, get this out of the frame. Others would say, just open the door on that visual. See? That's why different people think different ways. And my sideways, zigzag, and crooked way of thinking tends to yield results favorably most of the time. Even if not favorably, there's always a result. Oh look, you can see what I was talking about. So yeah, this piece, it's a 6-inch wide rim. I got a 6-inch wide plate that will index right there on those flanges. So, who wants to bet? I'm betting this is going to work. Name your price. You better follow up on your end when you lose the bet. We'll strip the powder coating off of this. We'll weld that. I got some reinforcements for this, some reinforcements for that. Some have said the steel 1/2-inch plate on the base will warp. I'm betting it won't. So I guess now we're just going to do a little montage, and I'm going to grind some steel, then I'm going to weld. And I came in a little early today because this is going to be a long and drawn out process. I may only tack weld these things and have the shape realized and testing tacked before I really weld the heck out of it. So either way, let's progress. So I guess I didn't cover this in the video, but I came in the other day, drilled a bunch of stuff. I had cut these plates, so I'm refining them. I got a hole saw that fits this bolt perfectly. So I did that. I did some other drilling for the hardware, for the ram. You know, I got some braces here that will weld to the underside. I got a lower mount created. We'll get into that. But to start it all off, I'm going to start right here because this is a big, heavy, and this is something to consider too. The steel temperature matters. So it's about 55 degrees Fahrenheit in here. Not a problem. I was working for a very short time in a big, they made, well, one section made rail cars and the other made, like, I imagine it to be bridge parts or something. It was called Kawasaki Rail Car, but they had two different, maybe they made rail cars and the bridges for rail cars. I don't know. Kawasaki Rail Car, Tarrytown, New York. I quit at lunchtime. I hated it that much, first day. Anyway, really cold in New York in winter, so they were welding beams. I mean, big beams. And on some of the days, it was said that they would postpone welding on them because it was so cold. On the day I was there, they had a whole preheat thing going on. This is about 3/8 wall. This is about 1/2 inch, so I don't think any preheating in this temperature is necessary. However, we don't weld on rust. Dig it? So let's clean this, and we're going to bevel it a little bit. We're not going to bevel it 100%. When I say that, I mean a V groove with a space in the bottom is the proper setup for thick metal. But I do something a little bit different in this regard. We'll get into that. Let me just grind this stuff. I know, I can hear the heavy metal fabricators chiming in. Weld joint preparation is everything. But because of the way I set these plates up, a perfectly beveled, prepared weld joint in this regard isn't necessary. All right, I'll let the cat out of the bag. It's because this plate is wider than this beam. If they were perfectly flush, you'd have to cut all the way in, but we're gonna have a weld on the outside. So it's a fillet weld appearing on the outside with a groove open in the bottom. I know it's a lot of talking. Here we go. How far do we want this? About to there. So here's the deal. This goes on here. We're gonna center this, but maybe I'll bring the camera up close here. So you can see that this is a little bit wider, right? And that's what I was getting at. So we do have, I beveled this a bit. What I'm gonna do is I'm gonna put in a little piece of welding rod right there just to lift it up a little bit. So I'm just gonna start right here. See, that's what I'm describing. Let me just set this right here. Yeah, maybe I'll put 2 of these. See, if I put these here, then, see, now we got an open groove for the weld to go inside. And, yeah, that's a considerable groove. I wonder if I want that, though, because, see, this piece... Well, yeah, I think that's okay. I think I want less gap. Let me see if I have a smaller wire. Yeah, I think I'm going to go with this smaller wire. Because I don't want to space it apart from the bearing too much. If you can follow my reasoning with that. I want this thing close, but not wiggling. Not like out in nowhere land. It's gonna be over here, like that. Yeah, so I like that. Cool. Yeah, we got it even Steven. That's cool. Yeah, so I think I'm gonna tack these 4 corners, then flip it and do the other side. Because again, I mentioned even heating, and that's really what this will accomplish also. I get down and dirty right here. So see how you can see a little light through there? That's the whole idea. And I'm gonna crank this welder. I'm using the larger one this time. 035 wire. And that thing will cook. That's what we want for heavy metal. This thing has been stored for quite some time, so hopefully it just comes back. Hasn't been through any trauma per se. Yeah, so my heat right now is at 20. I think that's probably cool. My wire is way up. So I'm gonna try 20 and 275 wire speed on this just to see. And if you remember from the other videos, when it's snap, crackling, and popping, it's a different heat range than when it's like slowly, like you'll hear it like dripping the steel into place. When you're welding with higher amperage, higher heat, you're gonna want better gloves. And when we get into welding these beads, I'm gonna have sleeves on because you will get burnt. Not only burnt by sparks, burnt by the arc. And then my helmet, of course, you turn the where is it? Oh, the shade, yeah. So I'm on shade 12. This goes up to 13. So yeah, you want a deeper shade. So yeah, right about there. Yeah, about 12, 13 for what we're working on. You can read about that in any welding manual. How the amperage and the shade of your helmet shall coincide. All right, we got that set. Now let's just take a listen to what it sounds like. That sounds good to me. That is hot and spicy. You can hear it crackling. Yep. Melted right in there. Really nice. When you're welding on a car or maybe another large structure, you will many times have to weld in out of position, you know, overhead, meaning you're upside down, or on an angle. Yes, locked it right in there. But we have the convenience of being on a table, so I'm going to rotate this beam as we work. Yeah, that definitely did its job. So the remember the welds shrink as they cool, and it trapped this stuff right in there, but it'll come out. So I'm going to flip this over once. Somebody cringed when I mentioned this falling off the table on my toes. That's a real possibility for anyone doing this type of stuff, so be aware. Never let it fall off the table on your toe. So what I'm going to do is get this corner. Yeah. That temperature is optimal because it's starting to drip off if I just weld it with the torch angle wrong. So with the torch angle right, it will penetrate right in there. Yeah. And this weld will be multiple passes too. I got a pass going in for penetration, then there'll be a nice top cap. And with this type of welding, no weaving, no acrobatics with the welding torch. Just a nice, your torch angle going into the weld is important, and the speed of travel. With sheet metal, you'll see me all over the place, you know, bobbing, weaving, tacking. Not the case with structural stuff. And you can, it's just, you want a solid weld with no imperfections, no defects, no inclusions as they're called. You really won't have any inclusions with MIG welding unless there's like, you know, some sand or something in the weld. Inclusion in like arc welding will be, you know, the coating on the rod, the flux, sometimes will get trapped in your liquid weld bead. And that ain't strong, bottom line. All right, I'm gonna prep this one. Get that in place. Now, you know what? I was gonna set this up like this, but I just realized we need to have these things perfectly straight. Now, how do we accomplish that when this is lifted up? I think we gotta rotate this. Without dropping it on our toes. See what I'm saying? We want this to meet this. Probably have to get these fit up a little bit better, I think. That side's good. Why isn't this side good? To get my Sandaroonie on there? What's wrong? Oh, remember I hit this with the hammer to take that bearing off? Yes, this is what I was hitting. I'm gonna sand this, I'll be right back. Yeah, I can see the hammer marks. Here's a note to the general public. Don't go bashing your perfectly round tube with a hammer, unless you intend to deform it. Get that. You see what I'm doing here? I'm making a perfect straight shot through. That way. Everything's in symmetry. Happy little symmetry. Oh, these are hitting each other now. That's why. All right, so either way, there we go, like that. This is gonna have to come up just a hair. Yeah. Yeah, so looking at the table, yeah, so that gap looks even. We got that there. That looks good. These are both on the end. Now we will commence welding this one. So with the root gap, you know, with the gap between the H and this, that's what I was saying, see? You got a little bit of flux, a little bit of slop in there, but I'm not worried about that. If I have to, I could put a little bit of shim stock in there. That should be adequate. I bet I won't need to though. Okay, let's get this welded. Yep, love that setting. It's hot. All right, we got that tacked. Let's spin this. So when I say tack welded, you can see this is going to support a lot of weight. So I'm just doing some smaller welds than what will be presented lastly. All right, I'm going to build this up a little bit right here. I ground this material a little bit too far away, so I just filled that back up. Cool. So we got those set. Flip this and get that last bit. So this is the thing too. The duty cycle on the welder. You know, this building has what I'm assuming is good electrical service because it's all pretty new. But again, not trying to break nothing. So I'm gonna take my time with welding this. All right, I believe this will be enough to test this without any weight on it. So I ground too far here. Let me repair this. All right. And, you know, our hinge, whatever, our tube is here. And there was some discussion about that and the strength. But we'll get to that eventually. There's going to be a lot of additional strength added to this besides the welds supporting the load. I ain't trying to have this break. Trust me. Trust me on that. All right, so we did that. Now we're going to work on this base. Here's what we're working with right now. All right, so this is pretty much always the deal for me, and probably anyone with limited resources regarding, you know, your shop power, amperage, welding power, etc. So I do it in pieces. That's cooling. we'll continue on. I cut a bunch of gussets for this also. People were talking about that, and I brought it up earlier. This is the vertical piece made to form. So I got stuff. Trust me on that. All these plates are going to index in there because we want it to look cool too. That's what those are, 1/2-inch plate. All right. So now we'll come back to this, again, the vertical piece. And we got, this is our base going on here. And then this piece came up and back. I wish I remember what angle that is. I don't, but I'm gonna clean this. This won't need to be beveled because there's a perfect fillet weld right here. And I could do 3 passes. I could do a center and then 2 cover passes. They'll be very strong. So let me just clean the rust off this. Another thing I was getting at, by doing it like this, it's giving the welder a chance to both cool down and, you know, there's a duty cycle in welders, so just giving it a rest. So we're going to set it like that because that is the pivot end. This is going to go here on my line on the table. This goes here, and as I remember, we wanted that 6 inches from the end because we needed it 3'6" at the bottom, and the table's 4 feet. So that's 8. Let's bring this more vertical. There it is. Oh no, it's this one. Right. So we gotta come back. 3'6" right there. Cool. Is it? Because this one, you only get one chance at this, kids, so let me double check. Without dropping it on my toes. Hi-ya. That is gonna go there. A lot of times there's nothing like the real world mock-up, is what I'm getting at. Yeah, see? It's gotta be a little bit lower to allow that. Is that the case? Oh no, this sits in here like that. That's why. That's what it is. That goes there. Goes there. That happy little piece indexes in there. There it is. Right. So see, we want this right on the precipice. Right on the edge of falling apart. Dang, it's some heavy metal. All right, so that's locked. That locks. That looks good. Complicated, isn't it? The whole thing is we're trying to get the angle on that plate correct. Get a good ground over there. Now the welder fan has turned off, so it's fully recovered. See, that's what I was talking about, the balance of things. Yeah, I can weld this nice. Then we'll put the other plate on. Let's get a nice ground in place. See, I had to lift this up off of the base because we're a little short on material. So, you know, that's a little bit, I don't know why I'm putting all my protective equipment on. A little bit of a give and take there. Would I have preferred to drop this all the way down? Yes, but we got plates to support that now. So, you know, just over here wasting time and money. I want to see your crane, sir or ma'am. And one thing to consider too with this plate, it will warp with this heat. So, you know, I'm talking about multiple pass welding. That will warp this. So, series of tacks all through. And another thing, this machine has a setting on it, and I just realized it's set at that. With this heat and wire speed, it'll produce a weld bead about 3 inches, and then it stops. So that's a good way to set up timing for this type of tack welding also. But I'm looking here, hopefully we maybe can see it. You can see the heat from the inside, so I'm going to continue on that same heat line. Like so. So that is good and stuck. So I think what I'm gonna do, let me shift this out of that, hopefully. Yeah, cool. So I can set this here on the table, and we can come up with an accurate angle of this plate. How do we do that? We find something that's that tall, I believe. How else would we locate that? Well, we could lay it this way. Yeah, let's do this. We'll lay it here. Get it up on something the same height over here. And then we'll take the square off the table and make sure all the angles jive. Yeah. See that? What's that rocking on? I got a piece of something. Got some kind of crud in there. There it is. Cool. So see, I could take the framing square and get all those angles together. See what I'm saying? We're on the table. Now we definitely want this moved this way. I'm gonna go buy another big old hammer because I showed you that one broke. One of my favorites. Little hammer will do the job for the moment. Yeah. We got that. We're coming here. That looks perfect. And we're coming here. That looks great. I'm not convinced that this is perfect because we're off the seam of the table. Maybe this thing over. Still good. I feel like that ramps up right there because of where the table is seamed. Yeah, that looks good. Yep. Yeah, now everything jives. Cool. Over here. Yeah, can't argue with that. Now just for double checking this, let's go check this out. Yeah, because the bottom is the most critical. Perfect. You know, I cut these plates by hand, so if it's just a little bit off, I mean, it's 1/16 off. As long as the base is jiving, when it stands up on its pivot, it will look straight. You don't want it to be leaning over. All right, cool. Let's tack this. We'll roll it over and really get in there and give it the business. So you could hear that big, hot, confident weld and the way it shut off automatically. That's what you're looking to do with this structural steel. Burn it. So when I say big, hot, confident weld, I'm meaning you don't hear it like popping back or stopping and starting, misfiring. All that reduces heat. So you want it, as I mentioned, confident, just a big, hot burn. You hear people use the term like bubblegum welds, right? Where it just looks like all blobby and lifted up. Not gonna serve you on structural steel. On sheet metal, yeah, you could give and take a little bit because it's thin. Cool. So I'm gonna go ahead and blast this again. I wonder if I should, yeah. Yeah. Cool. Well, that's decent. Let's see what that stands. Yeah, so it's gonna be sitting in the truck like that. Pivot there, and let's build out the bottom of this a little bit while this is gonna cool down a smidge. What did I do? I got these. These are going to be the gussets I was talking about. We got 2 and 2. There's going to be a larger one and then this smaller one up here. And then for the base, I think I had this back here. Remember, we're going to have to get in there to attach this. There's going to need to be an access hole. So I think that's what I did here. I think this came up, yeah, like that. Boom. Exactly. So we can reach our hand in there. So let's get this set. Yeah. Where's that chalk? I just saw it. So this is gonna come here, like this. And it's gonna land just like that. Let's clean that. And this one I'm going to weld 100% because the weld isn't that big and it's not going to warp this. In fact, this will help prevent warping. Welding inside here is going to want to pull these two in. So this will stop that. Yeah, kind of like that. Yeah, just like that. Cool. Get a ground. It actually did pull it in a little bit, but not a foul at this point. Let me hit this. Hit this. Hit that. Cool. Let's step over. I think I could reach that from over there. Well, it's locked now. We'll just spin it a little bit. Come over and weld that side first. Now this, the way that it runs the arc, the time is set, so it's gonna run it right out. So it gives you that much time. I'll step over here. Step back, and I'm gonna just continue this weld straight through. Something's changing. The wire speed's slowing down. Maybe the tip of this is heating up and starting to bind a little bit. Maybe there's a little kink in the hose. Not sure, but the weld bead is okay. All right, so that's the first pass there. Come in here and do the same. All right, see, I mentioned this earlier. I'm staying with my skin away from the arc. Keep your skin away from the arc. All right, so more welding to come on this. It's warmed up. It's gonna stand. Maybe I should hit this once more. Well, no, that's cool. There's going to be a plate here that supports the ram. There it is, that plate right there. I thought it was, no, I guess it goes there. Yeah. Let's put that plate on and support the ram. Pretty good. I was just laying on the table. Had sufficient contact. Put that down. See, it's cool and it's lifting it up. I should have tacked it. There we go. All right. First pass. Across both of these. All right, cool. Let me drop one right down in here. All right, so again, this will be trimmed later. I did send this out just a little bit. I'm trying to cheat that ram as much as I can. You want it as far out as possible, so that'll sit somewhere in there, vertical. All right, that's a pretty good mock-up of that piece. While the welder is recovering, here, I'll let the welder rest, and I'm gonna prep this rim. We're gonna make a ring on the slip roller, because this will be the next step. We're gonna put this in, and we're gonna figure out this, how this is going to attach. You know, we have to reach into that to get to the lug nuts. And I can see that the distance of that already will not allow a lug wrench in. I have a plan though. I have an idea, a course of action. Trying to fence off all the criticism. That ain't gonna work. Once you get used to these flap discs, you're always looking for the fresh one. It's a little bit of a curse. I mean, I thank everyone for sending these, but I love when they're brand new, especially for taking off paint and stuff. Nothing like it. All right, so we got that prepped. When we weld it, it is gonna smell. I'm gonna have to open the doors because I don't wanna clean all this powder coating off. Just gonna wire wheel it once it's kind of bubbled up. But I got 5-foot pieces of that material sheared. So I'm just gonna roll that in the ring and we'll kind of see how it compares to that. Smaller, bigger, I don't know, we'll find out. I am letting this welder run just to let it cool off. Hopefully our mics are good. We had that microphone incident on a couple of videos ago, and it wasn't on. No wonder it couldn't sound right. Hopefully we're past that. All right, we got that. Yeah, this should be long enough. I don't know, let's put it right through the center, see what we come up with. It's probably set a lot too tight. Drop this back. I don't know what the capacity of this is, but being that this material is only 6-inch wide and 1/8 thick, I think this might work. Probably have to do it in a few steps. Yeah, that looks like it might go. Let's try that. Put it square in there. It's gonna be good. Whoa. Whoa. Yeah. Definitely the capacity of this machine. Yeah. Whew. Just gonna size that up real quick. It's got to be considerably smaller, but a 5-foot piece will go around that rim. Just gonna roll it through once more because it seems a little bit egg-shaped. 10 years ago, I'd just be muscling right through this thing. I imagine a big ring on this, and it bolts to the floor. Or a variable speed gear-reduced electric motor. Yeah. Still ain't the right diameter. Maybe I'm gonna do some welding and, let things rest. It's gonna come around. Let's talk about the disc. All right, check this out. Our bolt circle. I think our bolt circle is 6.5 inches on center, and our H-beam is 6 inches. So our plates coming down are about 6.5 inches on center. That means to get a lug wrench in there is going to be super challenging. And also, I believe the bigger the hole we cut in this plate, the less strength we'll have. I digress. What I'm thinking about is one bolt. In other words, to take this off of the truck, there will be the center bolt. So you'll reach in a hole this big. If I reverse these studs, dig it? Not reverse the plate, reverse the studs. The rim will be mounting. Well, no. The rim will be mounting on this. Oh, no, my bad. The rim will still be mounting on this. But the studs, that'll work. I might have to double nut it. Let me see if I can hammer one of these out just for discussion. The thought I'm getting towards is we unbolt this, and then the hub and everything comes off, and then you access the lug nuts from inside it. That we don't have to worry about a big hole, small hole. The key is, will this just pop out, I hope. We don't need this much stud. Said no one ever. We need as much stud as possible. Anyway, see what I'm getting at? Let's put this here. Let's just see if we can't ding-a-ding that through. Sure can. So, yeah. I mean, we could take a lug nut. Could go by 8 more. And I don't think that's going to affect this either way. Let me explain. I'll just do 4 and 4 to mock this up. So basically the acorn shaped nut that indexes in here looks good. Then, yeah, no, it might not work. No, it needs to be long. Well, you know what I've seen, washers with this little flange on it. Yeah, I'm gonna work on that. I'm gonna find something that'll slip on here with this little tapered piece. But either way, these will go through the rim. I mean, that might almost work, just a stud alone with a washer on it. See what I'm doing here? Then we can put the flat end of the lug nut right there. So, yeah, that'll work. That way we got a small hole in the top plate. You dig it, you take this off, the whole kit and caboodle comes off, and should you need to do this, I don't see why you'd ever need to unbolt this in this application. You could change the bearings just by taking the center nut out. That's a go. Let's find the center of this plate. I like it. Let's find the center of the plate. Then we'll get back on that ring roller. That thing is no joke. All right, we went through this with Heidi and the bug rim covers. How do you find the center of that circle? We went over and over and over. I don't know. Let's try this. It's a 16-inch disc. I'm just gonna pick some spots on this table. Yeah, look, there's the center right there. Yeah, that's cool. So no matter how you slice it, once you get something that's roughly in the center of the plate, you know, it's kind of like a spirograph. Remember that game? Anyways, I got a whole series of scratches. You might not be able to see it, but I can, and that's the center right there. I'm just gonna take a large hole saw, make a hole right there. And then this for the center nut, that should totally be adequate. Ah, yes, the center nut. See what I'm saying? You just reach in there. Done, done. Enough room for a ratchet. Or socket, I say. All right, cool. Got this set up for that. Correctamundo. Let's go to the drill press. Ooh, don't you know about that? Drill press cannot drill to the center. Must be why it's called a 15-inch drill press, and not a 16-inch. No, I don't know what this thing's called, but it can't get to the center. Amazing. Good thing I have a cordless drill. So yeah, in a perfect world, would I have a giant machine shop at my disposal? I sure would. You know, all that discussion got me to thinking. When I say discussion, I mean me splaying out all my insane theory. I digress. My theory was not insane. I started to think that this hub would be trapped inside here, but it's not. It's on this side. So if I had to change the bearings, yeah, the hub will come right back out the bottom. I was starting to get a little bit concerned about welding this in place, what I was getting at. So yeah, to put these studs in, I think will be a little bit of a challenge. You know, you'll have to drop them in, but I could tack them right now. In fact, I should probably do that. I'm gonna knock all these studs out and tack them in place. That way that hub will just index. Then I can weld this on. Boom. You can see clearly where the bearing is. Nut goes right in there. How hot we got. Whoa! Oh, come on. And Gargantua sets in place like so. Are we all starting to understand now? This rotates, maybe some cool decorative pieces, and the plate on here. You know, something to spread out this load. It's time to go back over to the slip roll. Come on, it's adding up though, right? I don't know what the heck I just did, but it's way smaller. We're just gonna have to live with that. So, started off a little bit tight at the beginning. Let's see how that works out. Project's taking on some considerable weight. But I'm real happy about the way this is happening. All right. Heck yeah, it's just about perfect. Cool. So it is too tight right in here. So I'm gonna stretch this over the ring. Yeah, perfect. And I'm gonna hit this with a hammer a little bit. You can see it's just a little tight right there. I'm just gonna go ahead and cut this. Oh, I just pinched my finger. Excitement around every bend. That just worked. That just went right in. I might even just overlap this and just leave it in there. I'm gonna get a ratchet strap and I'm gonna close this up and weld it. That's gonna work. You know, I was just thinking, aren't I the guy that's like always short on metal? Aren't I? That's a literal question. Yes. So why would I just bury a piece of steel inside this project when I can just cut it off and I'll have it for next time? And I just screwed up my ratchet strap. You're dealing with a pro here, folks. Here, I'll just strap this up. Scribe a line, and we'll save that piece on the inside. Yeah, that looks nice though. I like it. I like it. Yeah. So you can see it's overlapped right here. And I can see that they're matching. There it went. I'm so tempted to weld this right now. No, let's just mark it. So this is the flat end where the tool wasn't working, and there's a clear line right here. And I say that all the time with tools. You know, you got to put some into the machine before it starts to work. All right, so we're gonna cut these two, just like that. Put it all back together. See what I'm getting at? It's like a 6-inch piece of metal that would have been lost in there. And I'm gonna need that. My future self is gonna need that. I've widened rims doing this exact thing too. I made a really neat set of aluminum rims. When I first got a TIG welder, I widened them from 5.5 to 8. And same thing, but I had somebody roll 1/4-inch aluminum for me. Cut the rim, used the strap, worked out great. I'm gonna need that. Just a little patience. I wrote a song about that. Yep, big hit. Hot dog, look at that. If that ain't a fit up, I don't know what is. I love it. That looks good. I'll come in and just adjust that. Let's get a weld going. I think we're getting close to the end of this video for today. Nobody said crane was built in a day. Probably learned that in some history books. I mean, the fall of crane is a whole different story. Hope we don't get to that. But my fellow countrymen, crane was not built in a day. Just gonna tack this up after I clean this. That's something to think about too. Ooh-wee. Yeah, we got some crust on the situation. Welding the heavier steel with some rust, etc. You do get some splattering, and this one is starting to show. It's all stuck together now. Oh yeah, just tack this right around the clock, and we'll discuss what's coming next. All right, well, it looks like we made a lot of progress. Came up with some critical decisions. What I'm gonna do now is just continue welding, then I'm gonna grease the bearings for this spindle. I think next time we're gonna get onto that truck part of things, so. If you like the truck part of things, come on back for more. It's gonna be here welding.